Good afternoon students, my name is G Kiran Kumar, Assistant Professor from ECE Department. So today we are going to discussing about Digital Communication Laboratory. So in that we have first experiment as a sampling theorem. So we have already known about this, what is sampling and what is the sampling process, how we can execute the output by using sampling circuit. Here you can see the sampling theorem kit. In that we have a sampler circuit is there. Here this is the sampling circuit. So for this sampling circuit we have to give the input voltage from the function generator. Okay, so from the function generator we have to give the input here, right? This is for input and this is for ground, and this is the sample and hold circuit, right? So based upon the input voltage, the sampling circuit will give the output as a samples. Basically we have a continuous time signal as a input signal, right? As we have already known about what is the inputs of the sampling kit. That is, the first input is the analog input that is taken from the function generator. Let us see here, this is the digital CRO. In that digital CRO we have to calculate the how much input, that is how much analog input we have to give, and after applying the analog input voltage to the sampler circuit, we have to calculate the number of samples per that input voltage, right? So for that purpose, I am going to verify the input voltages, right? Here you can see, so one of the knob is connected to the red color. Here you can get the output from the function generator. I am considering this knob is used to select the type of signal, that is a sine wave signal. I am just considering here sine wave signal. So that is given to the, that is connected to the digital CRO. You can see the output of the function generator. Here I am just considering above 500 Hz as the input signal. After going to here, you can measure the values. Here you can see the frequency is 589 Hz. I am just considering a low frequency signal is given to the sampling circuit. Here this is the input of the message signal, that is the sampler have input as continuous time signal and output as discrete time signal, right? The simply process is converts now continuous time signal into discrete time signal by using sampler. That is the sampling process. Now let us see, I am going to apply the inputs to the sampler kit. Here the input from the function generator, that is the input voltage, that is analog input signal is given to the sampler kit, and we require a sampling clock. Okay, we require a sampling clock. Here this is the knob which is used to change the clock frequency. Just I am trying to see the output of the sampling kit. Here you can see the sampling clock on the DS4 output. Here this is the sampling clock. Okay, so after observing these two inputs, that is one is analog input, that is message signal, and second one is sampling clock. You just need to note down the values of frequency, okay, and amplitude, voltage peak to peak value, that is amplitude we have to consider. Okay, you have to note down the both the values, amplitude and frequency, or in terms of time period. Okay, that is more important. So after giving the message signal to the sampler and one more input, that is clock frequency can given to the sampler. Okay, the multiplication of analog continuous sine wave signal with clock frequency, you will get the discrete time samples. Okay, so internally what will happen? Let us see the output value of the sampling. Then we can identify the sampler or samples. Let us see here. See here, this is the output of the sampler. Here the number of samples are based upon the input signal. So for that purpose, you need to compare the analog input signal with clocks. Then you will get the how many clock pulses or how many samples you will get the output. For that purpose, I am just considering the input signal. Again I am giving to input signal for the channel 2. Here you can see. So the green color indicates the input signal and the yellow color indicates the sampled version of that input signal. Here you can see, after applying the clock frequency, the amplitude of the input message signal is discretized. That is in terms of discrete pulses. See, these are all the discrete pulses. Okay. So continuous time, discrete time. Okay. In this sampling process, we have to completely convert the continuous time signal into discrete time signal. So this is the output of the sampling kit. Okay. Right. So these are all the samplers of the input message signal. Okay. Now let us see the demodulation process of the sampling kit. So I am just removing the connections. Here I can see the sampling output is there. So for the reconstruction signal, we have to give that sampling output signal into input. Right? I am just giving one connection only. Now I am going to calculate the output values of the reconstruction filter. So here I am giving the reconstruction filter connection. Now let us see the reconstruction of the sampling signal. So from that sampling signal, we have to reconstruct the original message signal. So for that purpose, we have to connect that sampled version. That is, the sampling signal is given to the reconstruction circuit. Here see, this is the reconstruction signal. Okay. So for that reconstruction circuit, I am giving to sampling input here. So this is from here. Okay. Sampled input given to the reconstruction signal, and here we have one resistor. So here we have to connect the 4K resistor here. Okay, one end is connected to the positive and other end is connected to the second end. Okay, here I am connecting the 4K resistor, and here you can see for the reconstruction of the low pass, for the reconstruction of the original signal, the low pass filter frequency response is very, very important. Okay, if you want to get the distortionless message signal, okay, you can connect the resistor value as 4K and the capacitor value here, this is the capacitor, this is the capacitor. So the capacitor value is 0.047 microfarads. Here one of the knob is connected to here and other knob is connected here. Now let us see the output. So this is the reconstruction output. Here you can see the CRO. This is the message signal. What we have given the input as a output we will get. Okay. The original signal, that is message signal, is 589 or 590 kilohertz. Here you can see hertz, and here you can see the output frequency is 588. Okay. Almost all, both the message signal, input signal and reconstructed signal is same. Okay. With a little bit distortion. So if you want to reduce that distortion, you have to change or you have to increasing and decreasing the amplitude levels. So based upon that amplitude levels, you will get the variations at the reconstruction signal. So this is about the verification of sampling theorem. So this is the sampling theorem verification process. Okay. The continuous time signal is converted into discrete time signal, and from the reconstruction part, that discrete time signal is again converted into continuous time signal. So that is about the sampling process. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.